cloud. Well, welcome, ladies and gentlemen, to the Cabrillo Engineering and Design 7th technical presentation of the year. I'm so proud to say that. Today, we have a great young man named Brandon Ethridge, who's coming to us from North Carolina Agriculture and Technological School in North Carolina. And he is actually here, I believe, probably somewhere around the Pasadena area, as he does work at the Jet Propulsion Laboratory here in Southern California. He is going to be presenting today to you. So, Brandon, welcome. And if you would like to share your screen, feel free to do so. The stage is yours.
Here we go. All right. Can you see that?
Yes, we can.
All right, perfect. All right. Thank you so much for having me. You are correct. I am in Pasadena. I moved during the quarantine, and I started my career at JPL during the quarantine. So it's been all apartment-based work, but it's been okay. You know, I'm thrilled to be here, and I appreciate the invitation in general. Like I said a few minutes ago, please, everyone involved, I'm not sure if you're allowed to unmute yourself or not, but if so, and you want to put it in the chat, however you want to do it, feel free to stop me, interject, ask questions. I'm a talker, so I'm happy to have the discussions, 100%. All right, so let's jump in. So this background, someone drew on the screen. That's so interesting. I didn't even know you could do that. We use WebEx at JPL most of the time. So the background here is actually JPL. And JPL is NASA's Jet Propulsion Lab. And it's a little bit different from the other NASA centers, where it's not entirely regulated by the government. Technically, I am a Caltech employee that works at NASA facilities. So it's a federally funded research and development center. I would try to go into all the distinctions. Frankly, they're confusing. Easy to look up. Basically, they had a little bit more flexibility to have more fun, but also do the same NASA work. So let's go ahead. So here's some of my personal background. I am from Raleigh, North Carolina. I was born and raised there. I actually only first left the East Coast when I came for my internship in 2019. I don't know how well you can see it, but that bottom right picture is my family, and you can see that it is a big family. I grew up with 8 siblings in the same house. My father passed away when I was 5, so it was just all of us plus my mom, and everyone packed into the same little house, making that work, which was super fun, but super close. Everyone in my family, we are very close to this day. That was actually from a fairly recent trip where we went back to go see everyone because, as you can see from the baby pictures, I'm a recent dad. My baby is now almost 8 months old. He is all over the place, super energetic. Luckily, he's sleeping at the moment, but if he wakes up, I guarantee you'll hear him, just as a heads up. So it's been fantastic. You know, we're really lucky. My fiance and I are very fortunate to have this opportunity in the quarantine to just kind of look on the bright side. I've been able to work at home since my baby was born, so I've been able to see everything that happened with him, which is something as you get older and start having to think about your own kids, I'm sure you will absolutely appreciate, because it's like, I'm sure it's tough to not be around for that. So yeah, that's kind of based here. I studied mechanical engineering with a concentration in aerospace. And it actually took me 5 years to get my degree because I transferred schools twice. I went to 3 separate universities. Basically, I was unwilling to settle. I didn't know exactly where I wanted to go, but I knew what I wanted to do. So I went to a school without really vetting it, and that was not the right school for me. So I left, went to another school, also not the right school for me. So I finally found North Carolina A&T, which is a historically Black college and university. And I couldn't have imagined enjoying school to the same degree. I've never been a big school person, never enjoyed it a lot until I got this situation. And I'll talk more about that moving forward as well. Before getting this job, I had 3 internships, plus I participated in research at my university. And I've already touched on the dad. You can see the little baby pictures there. I also, in the picture at the top left, I played club sports throughout my time at North Carolina A&T. And we were traveling every weekend for several months. So really had to be on top of all of our schoolwork the entire time. So before I talk too much here. All right, so I already mentioned this for the college. I did transfer twice. It's exactly the reasons I said. And one of the things I'll mention later is as a high schooler, I wish that I had done the research to figure out which college I wanted to go to. Basically, I knew I wanted to be either a pilot or an aerospace engineer because I was just fascinated with how things flew. I couldn't believe it. Eventually, I decided, hey, I want to know more about how to make things fly. So that's why I went toward engineering in general. But I did not care to find out what school to go to. I couldn't really be bothered with looking. I said, I know what I'm going to do. I'll find it when I have to. Don't do that. Would not recommend, because transferring is not very fun. But ultimately, once I found the right school for me, it was pretty smooth. And a big piece of that was because my professors and employers were incredibly engaged. They cared about my future. They cared about me figuring out what career path I wanted to go down. And actually, when I got my internship here at JPL in 2019, my mentor slash professor was here with me for a faculty internship. So I can't stress enough, as you go through college with teachers like this that are disengaged, college, high school, all of it, don't burn your bridges. Make good relationships, because that is what will take you a very long way. Absolutely super important. Other things I did, I mentioned I played club sports. I attended career fairs at the university, and mentoring is another big piece. So I can speak specifically for JPL that they care a lot about who you are as a person, more so than just what you have on your resume. It's important. I mean, you have to do the work. You have to show that you're a hard worker and you understand things. But it was stressed to me in my 9-hour internship or 9-hour interview that they care about, like, what have I done as a person? Have I done outreach, volunteering, research? What am I doing with my daily life, my activities? What's interesting, right? And that is a big selling point. So always be open about who you are and make decisions that make sense for you and for your career moving forward. The paid research I will also talk about moving forward. Let me see. Okay, so my first internship was with a company I didn't even write in here, actually. It was a small company in Raleigh, North Carolina. And I got it my sophomore year of college after applying to over 150 internships throughout my freshman year and my sophomore year. I had absolutely none of them, not a single callback from any. All were just denials in email. So what I decided, through some really good advice from a family friend, I just Googled the engineering firms around where I was staying. And at that time, I was literally sleeping on the floor at my sister's house in North Carolina. And I was calling these engineering companies, and this is just as the summer started. And I told them, hey, I don't want to go back to being a waiter. I would like to progress in my college career. Is there anything that you have for a mechanical engineering student that is just trying to progress toward his career and get started? I called 11 companies that were in the area, and the 10th one actually said, hey, yes, we do have something, come in. And from there, it just kind of kicked off everything for me. That was a great internship, not really the work that I was interested in, but an incredible company that I'm still close with the owners today. And that led me into my second internship the following year, where I worked at Lockheed Martin, which, if you're interested in aerospace, you're probably familiar with. But that was a very interesting experience to go from the really, really small, and I'm talking, I think my first company had 6 total employees, to Lockheed Martin, which is a global brand, which, that was a big change overall, but really interesting, and I think super impactful for me. I would definitely recommend doing that as you go throughout college as well. So I did research throughout my college career. It was a good method that I could make some money because I paid for school myself. I could make some money while also putting something on the resume. Highly would recommend that as well. I did research in computer vision and robotic controls. This robot arm in the bottom right is the last thing that I was working on, just trying to figure out how to do just pick and place codes and things like that. Just a side note, robotics is extremely complicated. I learned so much very quickly, and I also felt like I knew nothing at the same time. There was a lot to it. So looking into research at my university was one of the things that I am very glad that I did. No one had told me to do it at my previous schools, or professors weren't responsive. So it's super important, like I mentioned previously, to get those relationships with your professors, with your teachers, someone that can say, hey, this is a good student that will work hard for you. because that is the best way to make good money while you're in college, or I don't know if you can do it in high school, but good money while you're in college while also progressing toward the career that you would like to have. Okay, so my JPL internship, I actually did this right alongside Angelica. So she's going to know everything about this. But we worked on an aspect of the Mars sample return project, specifically the second stage. So Mars sample return will be done in 3 separate stages. The first will be the samples being collected and brought to the Mars ascent vehicle. The second stage is when the Mars ascent vehicle will launch from the Martian surface into orbit, and then it is collected by an ESA orbiter, and that will be taken back to Earth. So we focused specifically on kind of a senior design-like project that focused on the second stage. And we were asked to scale down what the Mars ascent vehicle would look like and figure out exactly how are we going to launch this thing into the air in the first place before it boosts itself up to orbit. So my previous experience was in design, which is CAD related. This was one of the early CAD models that we had, where that cylinder is representing the Mars ascent vehicle that was carrying the samples for us. And we were exploring the option of using pneumatic actuators to launch this platform and throw it up into the air and let it ignite itself and take it all the way. It was a really great internship, an amazing group of mentors and peers that clearly I'm still friends with today. So absolutely was a huge impact on my career and my personal life. I will say that not every internship is equal by any means. For full transparency, actually, after my internship at Lockheed Martin, which is a good company, but I think it was a bad situation for me personally, I had a discussion with my older brother, and he told me if I do not enjoy my next internship, I should start looking to get out of engineering because I'm not enjoying it. And it's just such an intricate system to explore what engineering is, because I was working at JPL for this internship was the first time in my entire life since I started working at 15 that I was genuinely happy to go to work every day. I was excited to see what was going on. I was excited to do the work that I was doing. So, in high school, it was hard to make that distinction, to understand that engineering is encompassing far more than just schematics or just doing CAD designs or testing. It is an entire discipline or an entire swath of disciplines. But I'll go into that a little bit more later as well. So I'll move on from this. So my current job, I am a flight systems engineer. What that means is that I am a systems engineer for the overall flight system that is being delivered. I work on NISAR, which is a combination project between NASA and the Indian Space Research Organization. So we work very directly with India on this synthetic aperture radar. And what this will be is an Earth orbiting satellite that's going to monitor for climate change and natural disasters and other changes on the Earth's surface. And the requirement, so it has to do this, is that it will be able to measure changes in the Earth's surface up to 1 centimeter across. So one of the really interesting things that we can monitor for this is glacial iceberg flows. We can see if an iceberg moves even slightly. We can see if mountains are shifting in any capacity. So it's going to be something that provides us a clarity that we haven't seen previously. So it's definitely really exciting. There are a lot of intricacies that come with working with another nation's space research organization. So that's been a lot to learn. But I'm thrilled to be working on this project. I have fantastic mentors and coworkers around me, and it's exciting to keep going with it. I'll keep going.
We do have a couple questions that, if you don't mind answering, I know you said to kind of interject.
Please do.
The first one, 1 second. No, sorry, chat, I hit the wrong button. The first one actually comes from Kylie Yang, who's saying, how did you realize that the first 2 schools were not specifically for you?
Right, that's a fantastic question so the way that I realized it was by going out of my way to put myself out there for professors that did not reciprocate the interest. And I was very shocked by that, actually. My first school, just overall, this was UNC Asheville. And it's actually a very good school. My math professor was great, but it was all of the intro courses. Intro engineering courses are anyone who tells you that they're not weed out courses is probably not being honest, right? The entire point is to really push you early on to see if you're going to stick with the rigorous methods that are necessary to get through the degree. So I didn't have a strong foundation in my math, and that made it really difficult for me there. But also it was just the entire environment around me for that university didn't quite fit what I was interested in. They also did not have an aerospace program exactly. It was a joint program where you transfer to another university inherently. So I just decided I'm just going to go to a different school and get out of theirs. That other school I went to was also in the North Carolina system, and it was at Charlotte. Everything about my interactions with my professors there did not suit me well. I think that I was in a uniquely difficult situation because I was trying to play football for the school at the same time. I was living with my pregnant sister, which if you have been around your sisters at the time, it's difficult. It was fantastic to be there for all of it, but there were certain challenges that were associated with it that frankly was just difficult overall. And I just didn't have reciprocation from my professors. There was no understanding at that university for the situation I was personally in. I approached several professors about trying to do research, and they never responded to me. So that was something that was difficult to navigate. That's specifically what stood out about North Carolina A&T for me. My very first day of a class with the professor that turned out to be my mentor, I walked up to him afterward because he had mentioned that he did aerospace research, and he took me straight up to his office and we started having a discussion. I started a job for him the next week, right? So it's a super important thing that is honestly very difficult to measure before you get to the universities, what type of engagement you can have with professors. I'm sure it also falls on me for not doing the correct work to present myself. And that's an area that I've grown, but that was the big factor for me.
Nice.
Sorry, long-winded answer.
No, not at all. And I'm going to kind of follow up just with a question from me that at the high school that you attended, did you take like AP research there? Or is it, who gave you the idea of always asking about research stuff?
No, I did not take any research. I didn't even know that was a course that was offered in any high school, actually. So that's great. That's offered. No, it's something that I got from speaking with my brother-in-law, who is a professor. He is the only person in my family that does engineering as well, and he does civil engineering. And he just mentioned that he had people that did it. So I asked around my university and tried to figure that out.
Perfect. Excellent. We have another question from Ravino Makadon, who's asking about, is the best way to earn a job, like an internship from an engineering organization, to have recommendations from teachers or professors at your university?
That is important. That will be asked at almost all of the internships and jobs that you apply for. The best method is variable, right? If you have an exceptional GPA, that will stand out on your resume. I never had an exceptional GPA, but I had a lot of work experience, right? Which comes from those internships, that research that I did, the volunteer experiences that I've done. And then I also had the recommendations from my professors. As I mentioned, my mentor did the faculty internship alongside me. So it really is a combination, especially for competitive companies. You have to have kind of everything going for you at the same time. One thing that I think many of my peers in college did not recognize is the only thing you really do not want to do is just go to college, just do your work and go home. There are so many more opportunities available, so many ways to stand out from your peers that make a big difference, because at the end of the day, if your graduating class can be 100 to several hundred people, and if they're getting the same degree as you, what makes you stand out is what you've done during that time, not just your schoolwork. So that's definitely something to keep in mind moving forward.
Excellent. Some questions now from the first few slides that you talked about your internship at JPL. Andrew Purificacion is asking about how difficult was it to design the second stage of the vehicle?
So for us, that was it was difficult because we had changing information continuously, right? Because we were doing a very early on iteration of what was suspected to be the design, We had constantly varying numbers and scales and ideas of what was going to happen. That internship experience was incredibly unique. One that I was literally conceived by the two mentors that we had after we got to the company. So we got there, what we were given was cut, I believe. So they decided, hey, let's give them our own experience that could be highly useful. And for me, it was, right? So that the difficulty was not having structured information to follow. We had to figure it all out amongst each other. But that's also what, made me and Angelica close friends. We had to talk about absolutely everything because we were figuring it out as we went. So the difficulty was also the fun part for that.
And then one final question before we let you continue is going to be, does the satellite system that you're currently working on now, does it also keep track of soil types for agriculture?
I'm not entirely sure about that, actually. I don't believe so, because we recently launched a separate mission that was called SMAP that specifically looked at soil moisture. Now, this is a similar project where we've taken some of the heritage items that were used in SMAP, but it is a separate project. So I'm not entirely sure. I do not believe that we monitor soil moisture for NISAR. But also everything is free access. You can look it up as easily as I could for this, actually. So just type in NISAR to your Google search, it'll pop right up.
Nice. All right. Thank you.
No problem. So here, okay. So being a systems engineer, this is a term that I did not have a full understanding of until I started doing internships, because systems engineer is a fairly new distinction. When you're looking at colleges, there are very, very few colleges that have a systems engineer discipline or a degree that is accurate to what the industry is, right? Frequently, you will see industrial and systems engineer, which is completely separate. That is much more along the lines of actually industrial engineering, which is not what I do. What systems engineering is a cross-discipline engineer. The idea that you are looking at the entire system, not the individual components, which most of my peers have, computer science degrees, computer engineering degrees, mechanical, aerospace. It's all over the place, electrical. And the whole idea of being a systems engineer is that you are the interface between various technical groups, and your job is to make sure that the entire system comes together as it should and functions properly. So I interface specifically with the radar group that is developing this. NISAR has two separate radars that are going to be used. One of them is made by us, by JPL. The other is made by India. So it's my responsibility to make sure that we know everything coming along with the JPL radar and exactly how it's going to interface with the other subsystems that we are using here at JPL. And in the future, I will also be responsible for making sure that the India radar does the same. So there are a lot of details that go into that. Honestly, I feel like I'm cheating myself by giving that type of a summary, but it's about the best I can do as far as a quick explanation. Personally, I love systems engineering because I'm a talker, right? I enjoy having the discussions about the techno aspects. I love looking at things from that top-down approach and understanding how the entire project, the entire system is meant to function and figuring out the ways of doing that. Some people prefer the detail-oriented jobs, right? There's a mechanical engineering design job where you can be focused on exactly how things are going to piece together within one specific subsystem. And that is absolutely appealing to some. But for me personally, I prefer to have these conversations and to be that interface. And systems engineering is a lot of different things at the same time. It encompasses creating flight software code. You manage the test beds, which hold the different flight hardware that's being tested on. Systems engineers are responsible for assembling the spacecraft because they're the ones that know how everything is supposed to go together, not just how one item goes. And testing flight software, testing hardware. And I fall into the testing category. I largely test flight software commands on the hardware right now. Okay, go ahead and keep going. So outreach, I've kind of mentioned. It's one of the things that is really important. If you can do it, you should try to do it. It stands out a lot on your resumes, and honestly, it's just beneficial overall for you. Um, I personally was volunteering at elementary school near North Carolina A&T, and coming from a big family like mine, I'm used to having kids around me all the time. And my first time experiencing my first time with that not being the case was going off to college. And as soon as I volunteered at the elementary school, I recognized that I was missing a significant piece of who I was as a person, which was those interactions. Um, I did not have a day without being around children until I was 18 and in college. So it was completely different, and it was so refreshing to do that volunteering. And it goes a long way. It's incredible to see the impact that you can have on kids at that age, especially that are just looking for some attention. So even if you're uncomfortable with it, it's something that I think that people could make themselves do, and you would probably have a lot better time than you're expecting. I've also done mentoring of high school students and interns. Actually, I'm currently mentoring some interns here at JPL, which is a little funny considering I was just in their shoes, but you learn a lot. You learn a lot during the internship and at the start of your career. There's a very dramatic shift in that learning curve as you get going. I still feel like I don't know anything, but at least I can answer the questions that everyone wants to ask me. I also am currently a committee member for the Black Excellence Strategic Team for JPL. So I'm on the employee resource group here, just looking to make the Black experience a little bit better, minority experience better across the board, and to be more inviting, right? There are so few minorities in STEM that one of the things I had to discuss with my peers in college at a historically Black college is that they have to get over being uncomfortable in a room with people that don't look like them. That is just something that's just a reality of life at the moment, right? It's very common to be the only Black person in the room, and you can't just shut down if that's the case. It's important to be able to have those discussions and to be able to function as an employee. And for me personally, I thought it was important to help others get to the same point that I've been helped to get to, and that's why I think outreach is super important. Okay, I'm coming to the end of my presentation here, but this is just some advice that I wish I had received, especially in high school. Do your research on the colleges that you would like to attend and the programs that you would like to attend, right? The most important thing is not just what the school name is. The important thing is what is the program that they're offering. And the further thing is what will that program allow you to do? A really key piece that I've been telling the students that I'm mentoring is to look at actual job requisitions that are out from companies right now. Look at exactly the job. They'll tell you the description of what you will be doing if you get hired on. And in that same description, they will show you exactly which degrees they're accepting for their hiring process. It's one of those items that I never was told about. And I think that in high school, especially, I had a very skewed perception of what engineering meant. I thought I would get to be the one building the entire aircraft myself. And that is so far from the truth, it's incredible. Some people's jobs are just focused on one item for years at a time because everything is so complicated now. There's no way to build everything yourself. So absolutely would recommend doing your research and finding the right school. And as I mentioned, I transferred twice. You can get out of it if you have to, but it is absolutely a pain. So if you can find the right school for you that fits well and have discussions with former students that went there or current students that go there, any method you can to figure out where you're going to be for the next 4 years of your life, 5 years of your life, absolutely take advantage of it. It's very helpful. I wish that I had done that. Scholarships are a big deal. School's expensive, and it's really easy to just get caught up in what's going on around you and not do these applications for free money. It is free money that will pay for your school for you if you just apply for it. And there are so many out there that there's no reason to not be applying for them. And my personal advice would be to sit down, maybe on your Saturday when you have an hour, 2 hours, just scroll through the internet and find various scholarships that are specific to you that you could apply for, and do it. Just throw in the applications. The worst they can say is no. The best they can say is, here's some free money for you. You won't have to pay for this. There's really no downside. It's just your time. I've already mentioned the importance of the engaged mentors. I've been incredibly fortunate for that. And without my mentors, there's no shot that I get to where I'm at now. Personally, my plan wasn't to work for NASA. It was out of my scope. It's not something that I've never met anyone that worked for NASA. I never knew any engineers growing up. Eventually I learned that my brother-in-law was an engineer, but I didn't even know that initially. So that to me is the importance of having engaged mentors, people that are invested in your future, because they can help you understand what is possible if you go down certain paths and conduct yourself correctly. This wasn't something that I saw happening, but it ended up becoming something that could happen. And being reassured about that along the way and being told, hey, this is what you should do, this is what you might want to try and get into, is what made the difference. Specifically, research is a key point that I wouldn't have known to ask professors about doing research if it wasn't for my brother-in-law. And that research directly led to me getting an internship offer, which got me my career. Networking kind of goes in the same vein, but this is something Angelica can definitely speak to. I was all over the place when I was here at JPL. I did not waste any of my time at all. I made sure that if I had any free time at all, I'm scheduling it on someone's calendar so I can go knock on their door and have discussions with them and say, hey, this is me, get my face viewed by them so that I'm familiar, and tell everyone I am looking for a job here. This is where I want to be, and this is where I want to work in. Networking is so important. Like I said, my GPA wasn't great, honestly. It was good enough. I passed their qualifications, and I made it very known that this is the job that I wanted to have. So absolutely take networking seriously everywhere you go. That's in school, that's at career fairs, that's whenever you meet someone out that's a family friend and they work a certain job. That is absolutely everywhere. You should be considering that you're building a network all the time. I've already mentioned the searching job requisitions. I think that is something that I really wish I'd known, because it will give you the most clear-cut identifier of exactly what will happen if you do this job, and it tells you the steps you have to take to get there. Take a coding class, please. Oh man, I wish I had taken a coding class. Everything you do, it can be useful, honestly. I don't code every day for my work, but I do have to code sometimes. And debugging is the worst thing to have to do. It takes me so long. Absolutely would advise taking a coding class, even if it's just Python or C++, just something like that. I guarantee you it'll be useful. It's not like whenever you take a class and you're upset that you've never used it a day of your life. You'll see it all over the places and you'll recognize that you know it. And the last piece would be to understand your classes, don't just pass them. This goes back to exactly what I was talking about for my peers in college, who honestly, some of them had better GPAs than I did as well. But they would ask me questions when we're working on group projects that were outrageous, that they just clearly did not understand the content of what they were studying in any capacity. And I don't say that to be rude. I understand why they were regurgitating the information, because that's somewhat of the system that has been presented to them. But it's so important that you can have these discussions that demonstrate your knowledge and not that you're just doing well on your tests, right? That will be really key as you get into interviews for internships, interviews for career positions in the future, because not every interview is a technical interview, but you're very likely to have a technical question asked in your interviews. It's super important to understand what you're actually doing, even if that is at the cost of not getting the best grade. I've seen people cheating to get the best grades, and they end up not knowing what they're doing. It makes no sense, because as soon as you're in the interview, they see your GPA, they're blown away, and then they ask you questions and you don't know the answers to the questions, you don't get the job. It just doesn't make any sense. So definitely take your time to understand your classes. Studying is something that I did not do in high school and that I learned to do in college. So starting early would definitely help you. But the importance is just to make sure you actually understand what you're looking at and what you're talking about all the time, the context of it. It's the same thing as when you were growing up and you were reading and you were just reading the words off and your teacher asked, what did that say? And you have no idea. You don't want to be in that situation, especially when you're in a job interview. So absolutely take your time to actually understand the material that you're working on. That is the most important thing. There's no point in going to school if you don't know what you're doing afterward. And I think that is all that I wrote here. Oh yeah, my fiance wanted me to include the little picture of the baby. If there's any questions at all, please feel free to ask them. Otherwise, thank you so much for having me. I really do appreciate it.
Excellent. Well, thank you so very much for giving the time, and your baby is absolutely adorable.
Thank you.
A couple questions inside of the chat here. Ravino Makandon is asking, what is the most difficult part of your job as a flight systems system engineer?
Oh man, it's really hard to answer that question because I won't lie, my job is very complicated. There are just so many layers to understanding, and I'll say the most difficult part is understanding exactly how systems interface with each other. These subsystems that I'm mentioning are, someone has spent 10 years of their life just working on this one subsystem, and it's expected of me as a systems engineer to understand exactly what's going to happen when I plug this into someone else's subsystem. It's incredibly complicated. There's just a lot of depth. I love it because it's challenging, but I will never feel like I know everything going on. It's impossible. So getting up to speed and getting to a point where I could start answering questions was probably the most difficult. Besides that, it's always difficult, honestly. That's one of the benefits to me of the job, that I'm always going to be answering these questions and also telling people I don't know the answer to some of these questions, even though they might expect me to. It's not really possible in a real capacity. And for me, as someone that really likes to know what I'm talking about all the time, that was a challenge as well, to be okay saying, I don't know what this means exactly, but I can try to figure it out for you.
Excellent. Angelica actually added, for the students that may not know, can you explain a subsystem and maybe the ones in the project you are currently working on?
I can explain some of the subsystems. I cannot explain all of them. That would take quite a while. So thank you for pointing that out. I probably should have gone through that. A subsystem is a piece of equipment, basically. It is, if you think about your computer, your hard drive would be considered a subsystem here as part of your computer, right? For us, we have the solid state recorder, which is almost the exact same thing. It's recording all of the information that we are observing through the radars. The radar instrument controller that will control the JPL LSAR, the L-band radar, is what I'm responsible for on my side of the team. And that is exactly like you would think it is. It's the radar's computer that tells it exactly what to do, sends the commands to conduct observations and things of that nature. And the payload data system is what processes all of the information that we're getting. So just those three alone are incredibly interwoven. So I would use the payload data system to send commands to the radar instrument controller, which would then record information and send it to the SSR, which is the solid state recorder. And that's just one instance of one or a couple subsystems. And just kind of give you an idea of how these things all work together.
Excellent. Andrew Purificacion is asking, how complex are subsystems?
Incredibly so. Incredibly so. I have been working on the radar instrument controller since I started at the end of June, and I still look a little dumb to some of these radar guys when we start having these discussions, because they're bringing up all of the intricacies. As I mentioned, these systems, I'm not exaggerating, are developed for 10 years at a time. These are people's life work that they've been working on the entire time, and then they put it all together. So each subsystem is incredibly complex, which is what makes the job of being a systems engineer difficult, but also interesting, right? Any new information I can learn about these subsystems is exciting to me, and then I can pass that on, and I can understand everything that they're telling me about, say, the radar instrument controller. I have to already be thinking about, how is this going to affect the PDS? How will this affect the SSR? And I have to already know some of the answers in my head, or a method by which to find them.
Well, I guess that answers the next question. It says, what do you enjoy most about being a systems engineer? This is from Mary Lou Quintero. And what do you like about the work environment? So you kind of answered the first one. So how do you like the work environment at the Jet Propulsion Laboratory?
JPL is the most incredible work environment I've ever been exposed to in any capacity, from anyone I've even spoken to. It is a culture of incredibly intelligent people that are also very open and willing to share information. I'm not exaggerating. During my internship, pre-COVID, I was literally knocking on random doors, and people are in the middle of their day, and they were like, "Come in, please. I'll tell you all about this." It's just so exciting. Everyone's excited to do what they're doing, and of course, you'll get bogged down with work, right? Like, that's just the nature of it. I mean, but everyone is excited to be working together. That's not my experience from every engineering company that I've been a part of. That's not my experience from every engineer that I've met. Uh, and of course, you'll have stragglers here as well. But the overall culture is excited to learn, to explore, and to share that information. Uh, and if you actually, where I'm standing outside is within 3 minutes from JPL. It's a beautiful area, truly incredible to see. And if you're walking around the campus, the JPL campus is bigger than Disneyland. Uh, so, I mean, Angelica can attest. We were sweating walking from building to building. Our mentor would always get up the hill to where our lab was at, and he would be completely out of breath. So, you don't get quite as trapped in an office building as some other jobs that I've seen from peers, and it's just a very open and exciting environment.
All right. You mentioned earlier before we allowed the kids to come on about your unwillingness or you did not like mathematics very much. In terms of high school, what level of mathematics did you get up to? And how did you overcome just that? What did you do in your college courses to allow you to become the mechanical engineer that you are?
So that is a great question. In high school, I only went up to, I was lazy, honestly. In high school, I did my algebra courses, and then I was told, hey, you want to go into engineering? Maybe you should do pre-calc. And I said, I don't want to do very much. So I took an easier math course that was an intro to college math. And I was far above what I should be doing in that class, but I also, honestly, like I said, I didn't apply myself very well. So when I got to college, I actually never ended up taking pre-calculus. I just jumped straight into calculus 1 with a math professor that was known throughout the department for being the most difficult. He was a very happy guy, but he's also happy to fail you because he expects you to know exactly what's going on because he's teaching it well. That's one of the things that I could never complain about. He was a fantastic teacher. He was excited about math. He loved doing it, but I just did not have the work ethic at that time to easily pass it. And I learned it. That's the conclusion that I figured out. I cannot do what I did in high school, which is I kind of skated by. And as soon as I got into college, I recognized, hey, if I don't focus and actually start spending time studying, hours every week studying, I will fail this class and I'll set myself back and set my future back. Plus, I'm paying for it, so I'll lose money. And that was the catalyst for me to recognize, hey, my grades are slipping, and I can't say I've done everything I possibly can to pass. So I fortunately had some friends that were also in the course, and we set up time that we were going to go group study at least 3 days out of the week for several hours at a time with in a situation that was in the math department where the professor would walk by every so often. We can ask questions. So really, I had to rigorously study to learn it. Same story with Calculus 2. Calculus 2 is the worst for me. That was incredibly difficult for me during that time.
Excellent. Adrian is asking, how long did it take you from your first internship to where you are now?
My first internship was, oh man, I'm so bad with time frames. 2017? Do you know that one? I use my fiance for my time frame reference because she's far better than I am. 2016. 2016, the summer of 2016. Thank you. And that was not due to lack of effort for applying and going to career fairs. I sent out easily 300 applications. That is by far a downplay of the number between my freshman and sophomore year. And as I mentioned, I highly would advise to do that cold calling. Just if you're not finding anything, just call around. They even have opportunities for high schoolers sometimes in those instances because a lot of the smaller companies are owned by the person that you speak to on the phone. They will pick up the phone and say, hey, this person is really interested. I'll give them a shot, right? Definitely would offer that piece of advice to just call the places around you and see if there are any opportunities for you to advance yourself towards your career. Because for me, that's what made all the difference. And I can absolutely tell you, once you get the first internship, it is a dramatic difference as you go to career fairs, as you start discussing with companies. The first internship is the absolute key. So definitely go out of your way to make that first one happen. And I think you'll notice that things fall into your lap a little bit better moving forward.
Amanda is asking, when you do have to code for work, how difficult is the code? And how much time did you spend on learning it? Or how many classes did you have to end up taking in college before you felt comfortable coding?
So I took no classes in college that were specific to coding. I had a class that was MATLAB where we did a little bit of coding. Um, Everything else that I did, actually, my research is where I started learning Python. So I learned some coding through my research for computer vision and the robotics. Uh, the difficult thing about coding at work for industry is that a lot of times you're not developing the code for the first time yourself, right? A lot of times you're given a code that someone else has used and you're asked, make this work for you. So it is almost all debugging, right? Almost all of it is trying to understand exactly what I'm looking at to point it to exactly where it needs to go so that it operates as designed. There are sometimes you're asked to develop the code from scratch, fairly rare. For me, that's not typically the case. And I have a phenomenal boss who has made it very clear to me that I have to be the one to gauge how much time I should spend learning it versus when I need to start getting help. It's really difficult. That is one of the hardest parts about being an early career for me because it's hard to say, all right, I've spent enough time. You know, sometimes it feels like you're not doing all of the hard work that you possibly can. Whereas it's simply beneficial to the company for me to ask someone that is more familiar. Uh, so the code is incredibly complex to have to deal with, even for the small things. Sometimes it's just it feels unnecessarily complicated. So I do my best to debug first, and then I get some help from someone that's familiar. And once they kind of give me some guidelines, I knock it out myself when I have to.
Excellent. What are some, this is from Letty Patino, what are some of the hardships or adversities that you had to overcome while interning at JPL? And were there any mistakes that you learned from?
I'll be honest. You know, by the time I got to JPL, I frankly had put myself in a pretty good situation. I had a lot of hardships growing up, had a lot of hardships going through school. Um, so, I mean, I mentioned that my father passed when I was 5, but my mother also passed 4 days after I graduated high school. So I was fully figuring out adult life as soon as I finished high school. So, you know, getting the internship at JPL, I was like, oh, now I'm good. Now I figured everything out. There were hardships. I mean, when I say hardships in the respect of JPL, I would say it's more so just technical challenges and dealing with personalities. That's an everyday work thing. Hardship is something that I personally reserve for genuinely difficult situations and scenarios to get through in life. So I guess for JPL, some of the challenges were, as I mentioned, just dealing with different personalities on a new project like we were working on. Um, you have a lot of opinions that you have to navigate through, and when you're not on the same page as the other peers, especially when you're being recognized as a group, it's fairly problematic. You don't want to go into a meeting where you're presenting as an entire group and have conflict during your presentation. It looks really bad, really unprofessional, and very childish. So that was a little bit difficult to navigate, but not terrible. Um, I mentioned not having enough information and learning that we had to be okay with that was an interesting complexity. Um, because frankly, in a lot of your projects, you won't have all the information. You know, a key thing that I noticed as a senior in college, as I'm about to graduate, is I had peers that were getting upset at the professor for not giving them a template for a presentation. And it's like, you're about to go into the workforce. You have to figure this out, right? Like you have to find your own template. That's how this is. That's the part of learning to learn and learning to grow. You know, you can't expect everyone to outline everything for you, and that was a key part that I learned during my internship as well.
Were there any mistakes that you made at JPL or any other internships that really got you to think about how you do things?
I would say I was overzealous, and I was expecting things to be simpler than they were. Um, at both my Lockheed internship and at JPL, there were instances where I didn't understand the complexity of the design, and I thought I had a quick, simple solution, probably egotistical, thinking, "Oh, this is no problem. I already know how to fix it." And I really had an engineer at Lockheed that really broke that down for me. He was like, "Okay, you put this all as one piece. This is 70 pieces," and that was humbling to say the least, because I recognized, hey, I might know how this is supposed to look in my head, but I have no idea about what each individual component is going to mean. And a perfect example is just to say, when you're putting together a mechanism of any type, you have to consider how it's joined. And like, I wasn't thinking about screws going into anything. I was just thinking, oh, this looks nice. I've seen this in computer-aided design before. Everything has to be able to turn from computer-aided design into real life, and understanding all of the small steps for that was a big difficulty for me.
All right, well, that looks to be about it. It's at 3:55 right now. Brandon, I'd like to say thank you very much for all the information that you gave us from your time in college, even some of the stuff going back to high school. And congratulations on your new family. You look like you have a very beautiful family coming together. And I look forward to actually seeing what you kind of do in the future with JPL. And I hope you come back and visit us again as you continue to grow and learn, and hopefully come back and teach it to some of our students. So thank you very much for your time and energy.
Absolutely. Thank you so much for having me. I genuinely appreciate it very much. So thank you again. Thank you for setting it up. Thank you, Angelica, for reaching out. It's all very appreciated.
Thank you so much, Angelica. You constantly keep helping our students to see different lights of engineering, math, and science. So we greatly appreciate it.
No, of course. I mean, I personally want to thank Brandon, because for the students that might listen to this, Brandon actually helped a lot with me. He was kind of like a small mentor for me when we worked together, and he actually made me comfortable with networking. That's something that at JPL he could attest to. He was the one telling me, hey, you should make appointments and talk to all these engineers and be able to build that network. So yeah, thank you so much for listening to me and participating today.
Well, thank you again so very much, guys. You guys have a very wonderful weekend, and we will see everybody on Monday, guys. Take care.
Thanks so much, everyone.